So I'm Neal Gallagher. This is my presentation on 3D printing in our makerspace. So this is the 3D printer we have. It's a Wham-Pound Duplicator i3. Costs about $400, so it's definitely on the cheaper end of 3D printers. I know the last presenter did in a MakerBot cost about $2,500, so quite a big price difference. This is sort of more what our 3D printer looks like now. We have a plastic, just sort of a plastic bin from Walmart over top of it to sort of prevent drafts and whatnot getting into 3D prints and prevent warping. So the two main types of 3D printing filament that the two popular types are PLA and ABS. So PLA is a biodegradable plastic made from renewable raw materials such as corn starch, sugarcane. Aside from 3D printing, it's typically used for water bottles, plastic packaging material, plastic wrap, etc. It's considered to be more ecologically friendly than ABS. ABS is an oil-based plastic. It's a tough material that can be used to create robust plastic parts, or robust plastic parts for everyday use. Has been traditionally used in electrical equipment, Lego bricks, things like that. Here's some different thermal properties of PLA and ABS. You see the melt volume index of PLA is slightly higher than ABS. It means you can maybe print a little bit of it, a little bit more of it in a given period of time. If the glass transition temperature at which heat kind of starts to affect the material, slumping temperature, which it starts to become malleable, melting temperature, it's the temperature at which it melts. And then you have the printing temperature, which is what you might set the 3D printer's nozzle to when you're printing with that material. So for PLA, a heat bed really isn't mandatory, as the temperature difference between the freshly printed material and the material that you've printed already is a little bit lower, so there's a less chance of warping. With ABS, it's basically a requirement, as the temperature difference between the freshly printed material and the material that you've printed previously would be much larger. So you have to have a heated bed, heated print surface to print on, to sort of lower that difference and try to prevent warping. Overall, PLA is better suited for 3D printing beginners or for printing toys, as it's less susceptible to typical 3D printing problems such as warping. And printing ABS requires a bit more experimenting to find out the optimal setting between maybe your printing brand, your 3D printer, your filament brand, your 3D printer, etc. And here we have a little example of what a printed part warping looks like. You can see the bottom of it sort of curling upwards toward the part, so the flat bottom is flat. ABS is printed at a higher temperature than PLA, which greatly reduces the danger of clogging or jamming the nozzle. It requires less pressure feeding it into the nozzle. ABS tends to shrink with cooling, so the printing parts makes it warping and others may crack or split. To avoid that, use a heated bed, and like I said earlier, we have a plastic bin from Walmart over our printer. A lot of the more expensive printers already come with enclosures. This is sort of to prevent drafts from getting to the print and adversely affect it. Adhesion to the print bed is greater than using PLA. This can result in a number of problems. And to solve a lot of these problems, what we did to solve it, what we might recommend, is using a slurry of ABS fragments dissolved in acetone. And what this does, when you brush that on the print bed, what this does is when you're printing, those first few layers, it's sort of, the ABS sort of melts together with the acetone slurry that you brush onto the bed, and that can greatly improve adhesion to the print bed. So what we're using for our 3D printer isn't either of those two. It's polycarbonate. It's a high temperature material, has a good chemical resistance, it's really tough, good general heat physical properties, it's really heat resistant, it's great impact strength. That's traditionally been used in making of bulletproof glass and compact discs, even though you couldn't print bulletproof glass. Here we have a picture of a polycarbonate part. Here you can see it's bolted to a metal bracket, sort of for for a motor, and then pressure fit into some PVC pipe. To use polycarbonate, we had to make some changes to our printer. So the brand that we're using is Polymaker PC Max. The brand can change some things. Different manufacturing processes for filament can maybe change, different, has slightly different melting temperatures, etc. We have our bed temperature set 200 degrees C. It's about the same as ABS. Your extruder temperature is set between 250 and 270 degrees C. This is a lot higher than the Wanhao i3 was really ever meant to go. So that caused numerous problems. We have a glass plate on top of the stock sheet, and on top of that we have a build pack sheet. So we put the glass on top of the stock aluminum print bed because what was happening is the aluminum print bed was itself warping slightly. So we had a borosilicate glass piece that we put on top of that and just secured it with some binder clips. So that got rid of the bed warping problem. And on top of that we put a build pack sheet, as that's something that the Polymaker sort of recommends, because polycarbonate might have an even harder time than ABS sticking to the print bed temperature, sticking to the print bed. And then we replaced the stock hot end on the Wanhao with an all metal hot end. So the stock hot end on it has, but when you get it, it ships with a plastic PTFE tube right in the middle of that nozzle. What happens when you're running your printer nozzle at 270 degrees Celsius, that little plastic tube runs a very good risk of melting and then just causing a bunch of problems. So we replace it with an all metal hot end, and that way we can more safely run the printer nozzle at much higher temperatures. Another problem running the printer to its absolute limits has caused is the power connector going from the power supply of the printer to its main board couldn't handle the current going through it and burned out. And see, here's where the connector melted, and here's where it connected to the main board. Couldn't handle the current we were trying to force out of the power supply and gave out. Here's some 3D printed parts that we have that are in use. You can see here is a pulley mount. Here's some drawer slides for the robot. And so what this was meant to do is to securely pull pulleys and to lift sort of this ball in the competition. You can see them sort of in use. This is a picture of the competition. The reason that we needed to use polycarbonate, not PLA or ABS, is we needed a material that could handle the force that we're putting on it. So together with everything, these maybe had to support a weight of 20 pounds with these drawer slides and everything and pulleys that had to secure in place. That's it. Any questions?